morning, everyone. We did our project on monitoring changes in Zostera marina density. I'm Sergio Astorita.
Vincent Black.
Antigua Murray. Cameron Roberts-Capak.
So the grounds of our project is based upon the observing eelgrass density in Buzzards Bay, Massachusetts. There are many abiotic factors that factor into the density, and because we live in Massachusetts and there's 4 seasons, these abiotic factors vary through the year. Our field data was collected using an underwater HD camera, GPS, and an ESRI ArcMap collector. And our hope is that our research will become long-term in order to understand the effect of these abiotic factors into Zostera and Buzzards Bay, Massachusetts. So a little background information on Zostera marina. It is a subtidal marine flowering plant. It is abundant in tidal areas and shallow waters within Buzzards Bay. And individual plants are connected by underground complex segments of roots called rhizomes. And eelgrass beds provide a sediment stabilization, shellfish habitat, and nursery habitat for fisheries.
So a little bit of background on this study. This is the second year continuous study, and we had 3 sites that we focused on. So there was Cape Fields, Onset, and MMA docks about 10 meters off the shellfish floats. This project started because in the 1930s there was a wasting disease that really devastated the eelgrass populations in the North Atlantic, and investigations linked it to nitrogen loading from groundwater and wastewater runoff from the land. In 1991, the Buzzards Bay National Estuary Program developed a comprehensive conservation and management plan. And so eelgrass was deemed a significant concern. So they put forward methods to take aerial photographs and do GIS mapping of these eelgrass beds so that they can target research in areas with increased nitrogen loading and establish critical loads for those sources. The objectives of our project were to obtain long-term in situ data, which was temperature, salinity, and water depth. We used a splash drone to capture aerial photographs of our sites. We also established accurate polygon perimeters of each of the eelgrass beds, and we monitored changes to eelgrass beds from Jensen et al. And Benson's study. And we wanted to contribute to the ongoing study and establish long-term data for years to come.
Here, this aerial photograph highlights the 3 different study sites in the Buzzards Bay area. And then moving forward, the next 3 slides will show the highlighted eelgrass beds for each location. So location 1, we have the MMA dock. You can see the eelgrass bed there. This one's for Onset, our second location. And location 3, we have Hayfield. And big thing we were trying to establish was those perimeters of each eelgrass bed in our data collection.
So our methods, each week we went aboard the 22-foot research vessel Zostera. The Zostera is equipped with a sea drop camera and an armored pulley that we used to operate it to take pictures of the eelgrass beds. It also had a SIMRAD chart plotter and GPS, and that's how we plotted the precise locations of our buoys so we could find them each week when we returned to the sites. And so we had 3 buoy systems, 1 at each site. And they each had 3 different kinds of loggers to get water temperature, conductivity, salinity, and water depth data. And so you can see on the slide the 3 different kinds of sensors that we had on our buoys. These are a few pictures of our equipment. So you have the Zostera all the way to the right, the SIMRAD chart plotter where we put the locations of our buoys, the GTAC computer with the points around Martha's Vineyard. That's how we uploaded data on the eelgrass density at each of our sites, and one of our buoy systems with the loggers you can see, and we also have a float on it so that we can collect data at all tides even when the water's running, and the underwater camera that we used on the pulley to take pictures of our sites.
So getting into data analysis, I was the main data collector member of the group. So starting with light intensity for each location, starting with the dock here, we only had 1 light sensor on this buoy system located at the top, mainly because this was such a shallow depth, so it wouldn't make sense to have both. And in this one we found light intensity to be the lowest. And then for on-site you can see that we have the top sensor as well as the bottom sensor. And you can see how it really fluctuates between the top and bottom. And this was our deepest location, so that would make sense why it fluctuates. And this is also where light intensity was the highest. And then for Hayfield, you can see the top and bottom. This was around the middle between the dock and onset light intensity. Getting into salinity, you might see that how we have 3 dips in most of these locations. So what happened was with salinity and even the temperature, actually the temperature is more accurate, but for salinity we had algae growth actually on the metal electrode. So that was something we actually didn't check on. We were more focused on cleaning off the part that gets plugged into the logger. So to be more accurate, we did take a YSI measurement our last time in the field. So you can see for onset, we have around 30 parts per thousand, which is pretty consistent in our first few weeks. You can see on the graphic 30. For Hayfield, around 30, which is a little bit higher than we had the first few weeks. And then for the dock, we had 35, which is almost 10 parts per thousand over our first few weeks. So with that measurement, we were in a hurry because we didn't want to run aground. We were in like 1 foot of water, so like, I'm not sure if that is accurate, but again, we took those measurements due to that algae growth over the sensor. And then for water level, onset being the highest because it's the deepest location, and the dock being shallowest, so being the lowest. And then I included the temperature on each graph to kind of get a general read because some were inaccurate again because of the algae growth. In general, we found that the dock was warmer than the other locations, and Hayfield onset being around the same temperature, but towards the end, these last few weeks, they all had pretty much the same temperature. And then when we go out to the field to measure the eelgrass to collect the data, we put down our underwater camera and we capture a photo like that one, and then we fill out the information in the GTAC computer. So we ask the question of, is there eelgrass? If yes, we figure out what % density, as well as for epiphytes, algae, we get the substrate, the location, as well as the depth and any other observations. And then for each time we go out to our different buoy location, we fill out this sheet with the general observations such as wind, air temperature, water temperature, and we also took lux measurements from a handheld tool. And then I compiled all that into one sheet so it's easier to compare over time. This is just an example, this doesn't have all of our data sheets in there.
Moving on to the discussion, looking at what we found from the data we collected. And we're going to compare the initial year study last year to what we have found thus far. In 2020-21, they found that eelgrass continues to propagate in the fall outside of the growth season, and their average coverage area of eelgrass in the seafloor in their areas of study was 25%. It varied for for the 2021-2022. For each location in Hayfield Emily Dock, it's a 25 to 50% average coverage, and for onset, it's a 5 to 25% coverage. But this may be due to we had many different technical challenges on the boat with our GPS and cameras connecting, and with having less points of collection for onset, that might have resulted in a lower average coverage. And for 2020 study, they found that the epiphyte coverage varied amongst each site, but it was more abundant on the prone eelgrass, which means it's not as healthy and in decline. And the ratios of lively to new growth for 2020 to prone was depressed, and it varied within each site as well. They didn't have any light intensity data available for their study, but that's something we added in, and there was a significant difference as Cameron showed from the top to bottom sensors, and this can be due to different effluents in the water, nitrogen causing different growths, and that can distinctly impact the growth of the eelgrass. And Sergio will go into a little bit of the nitrogen data that we collected.
Yeah, so as we know, nitrogen concentration tends to be higher in the fall and winter months compared to the summer and spring months. I averaged the concentration of the nitrogen in September, which was about 4 micromoles, and then in November it was around 8 micromoles. This being said, we do plan on using a more in-depth research next semester with the nitrate data that we have. And so we plan on using that for hopefully in the future as well as other groups.
And with this, just kind of to highlight the difference in levels as the environment in the area becomes less productive moving into the winter, the shellfish aren't filtering the water as much. That's what filters the nitrates. So with less filtration in the bio working in the environment, that creates more nitrogen available in the environment. And the following 3 slides are going to show some variations in eelgrass coverage on the seafloor. The quality of the screen isn't very good, but the top images show a more densely covered area, and then the bottom 2 pictures show the less dense coverage. And that's something we were looking at on the health and viability of the eelgrass. So this is for Hayfield, and then we're moving on to Onset and May Dock here. And the big thing we're looking at is the light intensity and penetration. And we read various studies, and the main 2 were Costa in 1998 and Benson et al. 2013. And Costa found that large areas of populations of Buzzards Bay are near the lower light limits of eelgrass, which means with small changes in light intensity that can result in distinct declines in eelgrass abundance. And then and that's why we're trying to find that outer perimeter at which depths the eelgrass beds stop. And then with Benson et al., they studied eelgrass survival and retention rate in light based on light penetration, and they also were looking at the nitrogen enrichment, which results in the bottom light intensity reducing. And they found that a healthy eelgrass bed are receiving 23.7% light intensity, which is within the minimum light requirements, 10 to 25%. And moving forward, we have the MMA dock buoy still in the water. In this, it will remain there throughout the winter to collect in situ data. And with this, our goal is to collect a full seasonal range of data for future students to look at and observe. And then next semester, we hope to have troubleshooted all of our technical problems with data collection and various sensors and the technology on the boat. That way we have more accurate, we can collect much more data next semester to have more accurate findings. And then at low tide, we plan to use the splash drone again during good weather to collect some aerial photographs of the dock site. And in conclusion, we will progress towards outlining the polygons around each eelgrass bed on the 3 sites. We only have 39 data points collected this semester due to technical problems. We hope to collect many more moving forward. And then we're going to use the drones as said, and then continue to collect in situ data from the data loggers throughout the next semester. And acknowledgements, we'd like to thank Dr. Pepin, our project advisor and mentor. He always loved getting on the boat with us, helping us, and wasn't afraid to get his hands dirty. Professor Hubbard, always helping mentor, Massachusetts Maritime Academy, and the Marine Department for helping us, always letting us take out the boat and helping us with any issues we had. Here are our references.
Do we have questions? And the next group could kind of move up to get the gear going. Questions? Do you have questions?
Which of the 3 eelgrass beds would you say is the most healthy? Like showing the most like predominant amount of eelgrass?
Like, do you have that data? Like, which one's the?
So, which had the highest coverage was Hayfield and MMA Dock, but I'd say Hayfield was more.
Yeah, Hayfield is definitely our largest site, so it had a large area that the eelgrass coverage was also pretty dense compared to like the area where the dock is kind of a smaller eelgrass bed, so really the health based on
And
that.
each one of them is pretty patchy. Like there'll be some sections that have a lot that are more dense than some of the smaller.
He says along those lines, because he said the light was lowest at the dock. The sensor might be covered with eelgrass because it's shallow. I mean, shallow to me would have been the highest light, but it's not.
I think it also didn't receive as much light because it's more closed in, like the breakwater for the dorms is kind of really close to it, so in the morning it's